All right, so we're going to learn a little bit more about, quadrilaterals. But we talked about this yesterday. We didn't get super specific. We got a little bit specific about some parallelograms. Off the top of your head, without looking at your notes, can you list, I don't know how many there are, 3 or 4 or 5? Okay, trapezoid. Well, trapezoid. Is trapezoid a parallelogram, though? No. Name just parallelograms. A rectangle, square, rhombus. Kite's not a parallelogram. I think that was it, isn't it? Just those 3? Okay. So, and then just like a regular old parallelogram, right? So you had a regular parallelogram, right, which isn't the other 3. But then you had a specialized parallelogram, which would be what? A rectangle, then a square, and a rhombus. Good. All right. And what do we know about parallelograms? So if somebody stopped you in the street, tell me everything you know about parallelograms. What would you tell me? What about the parallel sides? 1 pair? 2 pair. Right. Both pairs of opposite sides of a parallelogram are what? Are parallel to each other. I gave you a little sneak preview yesterday. What did I also say about the opposite sides of a parallelogram? I said we're going to learn it today. Say it again. Yes, they're congruent to each other. Okay, they're equal to each other. All right, so let's start off drawing a parallelogram. How about that? Oh, why did it do that? Because I didn't change this. Let's change that. Let's change this. Come on. There we go. And let's slant it a little bit. You don't really technically have to slant it. It's just kind of what, let's do this. It's just how we normally look at it, okay? So when we see it like this, that usually represents a parallelogram to us. Now, the first thing that I had on there looked like a rectangle, didn't it? You could represent it like that too, but this is a little bit more general, and most people, when they see this shape right here, they think what? When you see this shape, you think parallelogram, right? Now, just it's sitting there right now. Does that mean it's a parallelogram? Just because it looks like what we're used to looking at a parallelogram? No. So if I did this and I did this, now what can I say about it? Now I can say it's a parallelogram, all right? And we actually, I don't think we talked about this yesterday, but we have like a little notation for a parallelogram. Yeah, it's just a little tiny one, exactly right. So if I was going to call this something, I would call it parallelogram. You know how we did triangle, ABC, we did angle, ABC, whatever. All right, that's kind of what this is. It's just the symbol in front of it. So we'll call this parallelogram what? A, B, what do you think? C, D, that's right. Now what's very important here is... When I take a deep breath in, it makes me want to cough. I hate that. I got to not do that. Anyway, all right, I think I'm good now. You can start anywhere. You don't have to start at A. You don't have to start at the top left-hand corner. It does not matter where you start, okay? I could have started at D if I wanted to, all right? And I could have gone like backwards, right, counterclockwise if I wanted to. It doesn't matter as long as you start at one point and you go in the same direction all the way around to where you started again. Everybody see that? So if I started at A, I could call this parallelogram what? A, B, C, D, which I did. Or if I started at A, what could have I, how do you say that? What could I have done? Is that right? Yeah. What could I have done? A, D, C, B, right. I could have started at B if I wanted to and call it what? Now, if I started at B. If I started at B, B, C, D, A, right. Or you could call it what? B, A, D, C. You with me on that? But don't you think the best way to call this is just A, B, C, D? Yeah. All right, it does look better. But it doesn't matter, though. You could call it any of those things. You cannot call it what? What's one thing that you could not call it with those 4 letters? Yeah, you couldn't call it AC, whatever, okay? You can't go across. You got to go around the horn is what I like to say. All right, you go around the thing. All right, we good with that? I'm trying to decide if I want to go through this mess or just go right to the theorem. I think I'm going to go right to the theorem. Okay. Let me see. I just want to make sure I don't miss anything. Yeah, I'm just going to go right to the theorem. All right. It is a theorem, so you can prove it. And what we were going to do is not really an official proof, but it was just kind of showing you why what I'm going to show you now is true. So if you don't believe what I'm going to show you right now is true, we could always go through that other stuff. But you'll probably believe me, won't you? Got to be careful, though. Because if you put too much trust in people, you think they know it all. But they might steer you wrong. So you got to get people to prove things. But anyway, I'm not going to steer you wrong, so we're good. So we have a theorem, and there's basically two things about this theorem. I don't think they give it a name, because I just wrote down theorem. Usually if there's a name, I would put the name of the theorem down, but I just put theorem. And there's two things. One says this, that the consecutive angles, and we'll use this picture up here to describe what we're talking about, because when I just say the words, you may not understand what it's saying. The consecutive angles of a parallelogram, see that's a parallelogram symbol, are supplementary. And we'll draw it on the picture, we'll talk about it. But we'll just write that one down right now. And the next one is pretty easy. It's like a two-parter, all right? Yeah, it looks like it, according to my notes. And the second part says that the opposite, I'll just shorten opposite, angles of a parallelogram are congruent. And I'll put the congruent symbol. All right, so let's talk about that. So look at the first one. The consecutive angles are supplementary. What does that mean? What does that mean about angle A? So give me a consecutive angle with angle A. There's two choices. B or D. That's right, okay? B or D. Everybody see that? So look at these two angles right here. It says that they're supplementary. Looks like I am kind of going back to what I was going to do earlier, but I'm not going to. I'll just do it little piece by piece. Why are they supplementary? Well, remember I got parallel lines, don't I? And this would be considered a transversal. Do you remember that chapter? Parallel lines cut by transversal. What are these two angles to each other? Give me that word that we use. Yeah, it's one of those. Which one is it? Consecutive interior angles. Very good. These would be consecutive interior angles. What did we learn back in the day when we first learned this stuff about consecutive interior angles? They're what? They're supplementary. So check it out. Consecutive angles, or we're only talking about the interior angles anyway, right? Consecutive interior angles are what? Supplementary. Does that make sense? So what does that mean? That means angle A is supplementary to D, which also means angle A, what? Plus angle D is equal to what? 180. Good. That's supplementary. You with me on that? I'm not going to go through them all, but let's do that. So watch. Let's go to B. What about A and B? Well, I got two parallel lines right here, don't I? Do you see that? Cut by this transversal. So these are also consecutive interior angles. Yes? So if this has one arc, what do you think this is going to have? It's going to have two arcs. All right? Because these two, right, these two add up to 180. So for instance, if this was 100 degrees, all right, we'll just say that. If that was 100 degrees, what's this angle right here? 80 degrees. Agreed? Now, what if this is 100 degrees? What's true about this? Parallel lines cut by transversal. These are also supplementary, so this must also be what? 80 degrees. You with me? So if this is 80 degrees, look at this. I got I got these two parallel lines right here. Do you see it? The top one and bottom one cut by this transversal. If that's 80, what's this? This is 100 degrees, right? Which has got one arc. Does that make sense when you put the numbers in? Yeah. So angle A plus D are 180, A plus B are 180, B plus C is 180, and C plus D is 180. So would you agree that all the consecutive angles are supplementary? Absolutely. All right. Now that also tells you that's why this is a two-part theorem, because what else must be true? Look at that one and that one. Angle B and angle D, what are they? They're opposite angles, aren't they? Do you see this? See how they're opposite each other? All right. And what are they? They're congruent. They're equal. What about these two angles right here? They're also opposite each other. So what's true about them? They're equal to each other. They're congruent to each other. We get that? And that's all because of the parallel lines, right? Parallel lines cut by transversal. We learned it a long time ago, and it's coming back. All right? I almost say it's coming back to haunt us, but it's not really haunting us. It's helping us. All right? It's coming back to help us. All right? So there you go. And that's why these things are true. So we kind of did give like a little mini proof, I guess, on why that's true. Well, that was easy, right? All right, let's do a couple more. Well, a few more. Let's draw this. What if I drew a parallelogram? Do you agree that's probably still a parallelogram? Yeah. But what if I told you that just one of the angles was 90 degrees? All right, let's figure out why. Well, remember what we just said? This is a corollary. Do you remember why we call it a corollary? A corollary has to do with the last theorem that we just talked about. So what was the last theorem we just talked about? The consecutive angles are supplementary and the opposite angles are equal, correct? All right, so this has to do with that last theorem that we just dealt with. So if this was a parallelogram, and they tell you it is a parallelogram, all right, so what does that mean? That means that these two are parallel and what? These two are parallel. It also means that this angle and this angle are supplementary. So if that's 90, what's this have to be? 90. 180 minus 90. Okay? Again, if it's a parallelogram, what do we know about the opposite angles? The opposite angles are equal, so that must mean this is 90. These two opposite angles are equal. So if that's 90, then what? This is 90. So guess what we have? We have a what? We have a parallelogram with all four right angles, so it's got to be a rectangle. This is a corollary, which means it's kind of like a step under that big theorem, right? Because it has to do with the same stuff that other theorem told us about, all right? So there's corollaries to a lot of different theorems, right? So you got this one big major theorem, and you're like, oh, if that stuff's true, then boom, this stuff's true. That's basically what a corollary says. So what the theorem says, and it's a theorem as well. I mean, it's a corollary, but it's just like a theorem that has something to do with the theorem before it. All right? So what does this corollary say? It says if a parallelogram has just one right angle, because that's what we started off with, right, before I put all those other ones in there, we only knew that that was a right angle. But if we know that that's a right angle, then guess what? All those other ones are right angles. So if all the other ones are right angles and it's a parallelogram, then it's a what? A rectangle. We got it? Okay. Let's do another one. These ones that we're doing right now are really going to come in to be important for us. And again, let's make it go the other way this time. All right. Now, here's a theorem. We're not going to really go through a proof or anything, but here's a theorem. This is what we kind of alluded to yesterday. All right. So it is a parallelogram. They tell us it is a parallelogram. It's given that it's a what? Parallelogram. All right. So if it's a parallelogram, what do I know about the opposite sides? They are they're parallel to each other. Okay. We haven't technically learned that yet, but we're going to learn it right now. All right. So there's also something else you know about a parallelogram. Parallelogram, the opposite sides are also equal to each other. So we know the opposite angles are equal to each other, right? And we also know that the opposite sides are equal to each other. And I think you could do this with, like, if you drew a diagonal from here to here, you could do congruent triangles, and you could show that the opposite sides are equal to each other. I don't have it written down, so I'm not sure how involved it is. It might be super easy. It might be a little bit more involved, but just believe me. I hate to say that. It's terrible as a geometry teacher to say, just believe me. Because geometry teachers are always proving stuff all the time. Go ahead, challenge me on it. I'll prove it to you. You know what I mean? But for right now, we're just going to say that that's true. All right. Everybody good so far? That was another theorem, okay? The theorem says, I'm not going to write that whole thing down for you, but the theorem says that the opposite sides of a parallelogram are congruent to each other, or they're equal to each other. All right, so that's pretty easy, right? If they told you this was 3, then what's this right here? 3. If they told you that was 2, what's this over here? It's 2. Or if they said this was 3x minus 7, all right, and this was 2x plus 1, then you could probably, I don't know if this comes out nice or not, but you could figure out what each of these are, right? Because you just set up a little algebra equation, 3x minus 7 equals 2x plus 1. Solve for x, plug it back in, bang, you got it. Everybody with me on that? Okay. Yeah. And you probably could have done that. That was pretty easy. All right, let's do another one. Keep the same picture there. Watch this. This is kind of interesting. Something you may not have thought of before seeing this. All right, these are 2 different diagonals inside of here, right? Go from one vertex to another, to a non-consecutive vertex. We talked about that yesterday. Go from here to here. And they hit each other, don't they? They intersect each other. But they don't just intersect each other. They do something more specific. Pretty much the midpoint of what? Of both of them, okay? They actually intersect the midpoint of both of them, or we use the word bisect. They bisect each other. All right. Again, you know that you have a parallelogram here. You got to know it's a parallelogram, okay? So if you know it's a parallelogram, then what can you say? You can say a bunch of stuff so far, right? You can say that the opposite sides are parallel. You could say the opposite sides are equal. You could say the opposite angles are equal. You could say the consecutive angles are supplementary. There's a bunch of stuff just today that we learned, right, and a little bit yesterday that we learned about parallelograms. But here's another thing. You could also say that they bisect each other, which means that this and this are equal, and this one and this one are equal to each other. Doesn't mean the 2 diagonals are the same. No, because look at this diagonal. See how it's slanted a lot more that way? So this diagonal looks a lot longer than what this one does. So it doesn't mean the diagonals are equal to each other. Okay, but they do bisect each other. Every single parallelogram. So even if your parallelogram was a rectangle, the diagonals would bisect each other, okay? If it was a square, the diagonals would bisect each other. If it was a rhombus, the diagonals would bisect each other. All right, even on a normal everyday parallelogram that's not a special parallelogram, the diagonals bisect each other. We go to that so far? Yeah, let's do an example. You ready? Do an example? I take that as a yes. Your silence. All right. It's actually already drawn like this, so it makes it nice. So we're going to call this parallelogram ABCD. And let's put some stuff in here. Put some other letter. Let's put one more letter, E, right there. So what do they tell you? They tell you that AB, I think this is, kind of wrote this example a little sloppy, but yeah, they tell you a bunch of stuff. They tell you that AB is 6.3. So where's AB? 6.3. Okay? They tell you that AE is 4.2, so this little bit right here is 4.2. BD is 11.6. BD, How are we going to do that? BD is that whole entire thing from there to there. Oops. Let's do one of these dealies. Is that all right? And that's what I say, 11.6. It's kind of a mess. Let's put some angles in here. Let's go a different color with the angles. ABC. Where's ABC? That's this whole angle right here. See that one? That's 72 degrees. ACD. ACD, that's this little one right here. We'll put two little arcs right there. And I'll put an arrow. And this one was, what did I say was ACD? 63 degrees. And they give you one more thing, ABD. ABD. All right, let's do it in a different color. So it's this. It's not the whole 72. Everybody see that? It's just from here to here. And they tell you that that's 41 degrees. All right. It's kind of a mess. But there you go. And they're going to ask you basically to fill in the rest of the missing stuff, basically. So let's slide this up a little bit. And let's find DC. Oops, that's DC. Let's find EC. Let's find ED. So those are sides. Let's find some angles. Let's find an angle DAB. Some of these are super easy to find. Some maybe not quite so much. This is ADC. And one more angle, DAC. All right, so they give you all that stuff. They give you a ton of stuff. And they also ask for a ton of stuff, all right? They ask for 6 different things. So let's do the first one. Let's do DC. DC, where is that one? Oh, that's easy. Look at that. DC is this one right here. So how do I find that? Do I have to do any math at all? No, all I got to do is look. Where do I look? At AB, at the opposite side. Very good. See the opposite sides? They're equal to each other. So what is CD? Tell you what, let's put them in pink. So CD is also 6.3. Would you agree? Since you already knew that, the opposite side 6.3, so we got that one. 1 down, 5 to go. EC. EC is from here to here. Well, they told you from A to E, didn't they? And what's true about the diagonals? What do? They bisect each other. That means this little bit right here and this little bit right here would be the same. Would you agree? Yep. So if this is 4.2, what is it from E to C? It's also 4.2. Wow, this is simple stuff. You know it's not always going to be this easy, right? Because they're going to put some letters in there eventually. They didn't on this one, but eventually they're going to do that kind of stuff. All right, what about ED? Where's ED? There's E, there's D. Oh, what do we know? I don't know BE, do I? But I do know the whole entire BD. I know the whole thing is 11.6. So how do I find it from E to D? What do I do to that 11.6? Divide it by 2, that's right. And that's 5.8. Okay, so ED is 5.8. It's not so bad, is it? All right, let's do some angles now. Let's go orange. Okay, DAB, where's that? There's D, there's A, there's B. So we're looking for this whole big angle right there. We can do it a couple ways. I'm looking up here. Do you see this whole big angle up at the top left? How many degrees is that? 72. So how do I find this one down here on the bottom left? That's it. 180 minus 72. And that gives you what? 108? And there you go. That's 108. The math isn't hard at all, right? You just have to recognize the relationship between these things. Okay? Are they equal? Are they supplementary? What do? All right? What about ADC? There's A, there's D, there's C, so I'm looking for this angle right there. Without any math at all, I can find that. Gabby, what do you think? 72, right? Okay. I saw it in your eyes that you knew it. All right, so look, that's 72. This is 72. Because remember, what's true about the opposite angles of a parallelogram? They are equal to each other. So if that's 72, then that is 72. Pretty easy, isn't it? All right, one more, DAC. There's D, there's A, there's C. So we're talking about this, not the whole thing, but this little bit right there. So what do you think about that? Yeah, so watch. If this is 63 right here, then this little bit right here is what? 63. Do you see it? You see parallel lines cut by transversal? These are actually alternate interior angles, aren't they? So that would be 63. So remember what that whole thing was? It was 108, wasn't it? So I know that little bit right there is 63, so what do I do to find that one? Just subtract. So 108, what? Minus 63. And that's what, 45? And there you go. You found them all. Look how colorful that is. Isn't that pretty? Looks like candy. Looks like you could eat it. All right. Everybody good so far? All right. Now, remember what I said earlier? When did I say we get out of here? 20 what? 8? Oh, man. All right. Well, we'll finish it up tomorrow. So, let's see. What do you have? Well, we got ahead today, but now we're getting behind again because we'll probably just finish this up tomorrow. So we probably... Oh, no, tomorrow's Thursday, right? So, yeah, we'll be right on track after tomorrow. So we're good. All right, so do as many as you can. If you don't want to do all the homework tomorrow, it looks like 1 to 17 and 21 to 24. Yeah. 1 to 17, 21 to 24. And this is section 6-2. My guess is you'll probably be able to do most of 1 to 17. 21 to 24, we'll probably talk more about that tomorrow, okay? Do as many as you can. It's not officially assigned, but do as many as you can.